802.1x, also known as EAP authentication. This is one of the most important authentication protocols that you will come across in the Wi-Fi world, right? And this IEEE.1x standard is not specifically a Wi-Fi standard. That's what people often mistake this for. They kind of think .1x is an IEEE Wi-Fi standard, but it's not specifically a Wi-Fi standard. And some people kind of refer it as 802.11x. That's also not true. It's .1x and not .11x, right? Now .1x standard is a port-based access control standard. What is it? It is a port-based access control standard. So it makes sure what access you should get, right? It's basically, that's what it is doing. Now .1x provides an authorization framework that allows or disallows traffic to pass through a port. That's pretty much what it means, and thereby access network resources. So we have to, with .1x, right, with .1x we authorize a device to be able to access the network resources or not by providing the right set of credentials. Okay, right set of credentials. Okay, in this particular chapter we are talking about the entire EAP framework. What does EAP entail? Okay, now a .11.1x framework may be implemented in either a wireless or a wired environment. As I said, it's not specifically a Wi-Fi standard. It can be implemented on either wired or Wi-Fi or both. Okay, so this can be done on both Wi-Fi and wired, wireless, right? Now 802.1x can be implemented, right? Cool. Now the .1x framework consists of three different parameters and three main important parameters. That's what the framework is all about. So .1x framework or the EAP framework, it consists of three different parameters. The number one is, or I should say three different components. The number one is supplicant. What's supplicant? A host with a software that is requesting authentication and access to the network resources, like your laptop, right? Any host with a software that is requesting authentication and access to network resources. Okay, this is what a host is. So now each host or each supplicant has a unique authentication credentials that are verified by the authentication server. I'll come to that authentication server later, but each supplicant will have a unique set of credentials. Okay, the second component is authenticator. Okay, now this is the device that blocks or allows traffic to pass through its port identity or port entity. Authentication traffic is normally allowed to pass through the authenticator, whereas all the other traffic is kind of blocked until the identity of the supplicant has been verified. Now what it does is, it allows, if when the supplicant is trying to access the radius server, is trying to send the credentials to the radius server, authenticator sits in between and allows the authentication traffic to pass through, so that yes, the supplicant can send the credentials to the radius server, but blocks every other type of traffic so that there is no access to resources given before the credentials are verified, right? The authenticator maintains two virtual ports. Okay, so I'm just going to write that down here. So this device either blocks or allows traffic, allows the authentication traffic to pass through, authentication traffic, and blocks every other traffic, right? Until the credentials of the client is verified. Now it maintains two virtual ports. Okay, you should know this. Maintains two virtual set of ports. One is called the control ports and the other is uncontrolled ports. Okay, so the uncontrolled ports or the uncontrolled port allows the EAP traffic to pass through. So that is this port allows the EAP authentication traffic to pass between the supplicant and the authentication server, which is coming up next. And the control ports blocks every other traffic to pass through. Okay, this is what the this is the role of a controlled port on an uncontrolled port. This blocks every other type of traffic until the credentials are verified of the supplicant by the authentication server, right? Next comes the third component is the authentication server, also known as AS, authentication server. Now this server it's a server that validates the credentials of the supplicant that is requesting access and then notifies the authenticator that the supplicant has been authorized just fine, right? So this is the server that is responsible to validate the credentials of the supplicant and then basically informs the authenticator that this client has been verified or this client has not been verified, right? So if it's been verified, you open up the control ports. If it's not verified, keep them blocked, don't give them access. Now the authentication server will either maintain a database of username and password. Either it can have a username and password database, okay, or it can query or it can basically proxy with an external LDAP server to validate the authentication credentials. Now it can either talk to external server using the LDAP protocol, okay, and then check the database that is maintained on this server. Either way it's fine. It can either have its own database or it can query another external server using an LDAP protocol and then verify if the credentials are valid or not, right? Both the things work absolutely fine. The AS can work either way, right? Now let's take an example. I hope this is clear, because if not, then you might want to repeat or you play this video from start. Supplicant, authenticator and authentication server, they are very important components of an EAP framework. You need to know what they're all about. Okay, now let's take an example of a wired network or wired.1x, for example. Just a quick view of that. Here the laptop that is plugged into a switch, that is plugged into a radius server, for example. This is acting as a supplicant in this. This becomes the authenticator, is the switch, managed switch, and this is the authentication server. Okay, this is what happens in the wired network. Now in wireless 802.11, I have a Wi-Fi client. Now it's a scenario where I am using standard, autonomous access points which are not dependent on the wireless LAN controller. So I have an access point here and I have a radius server here, basically having an Ethernet backhaul connecting it via LAN. I'm not going to, let me just do it like this because there's a switch in between also. But yeah, so this acts as the supplicant because the host trying to authenticate, connecting on the Wi-Fi. Okay, the AP, standalone autonomous access point, will act as the authenticator, will maintain the uncontrolled and the controlled ports, and the radius server will act as an authentication server in this scenario. Okay, Now in other scenarios where let's say I have a Wi-Fi client and we have a AP managed by a WLC, a wireless, it's a lightweight access point managed by a wireless LAN controller, and again we have a radius server connected to it, connected to one of the APs on this. This acts as the supplicant, this acts as the authenticator. Now the WLC acts as the authenticator and maintains the controlled and the uncontrolled ports. Okay, now in this, I mean, similar to the last one, the radius server will always act as the authentication server. Okay, now here there can be an LDAP at the backend depending on if needed or not, or the radius server can maintain its own database depending on how you want to set it up, right? Okay, I hope this is clear, because this is very important in what's going to follow. So you have to make sure that you understand this. So although now in the framework we understand that it's a supplicant, authenticator and the authentication server. So although these three work together to provide the framework for .1x port based access control, right? These three really work together to provide that framework. You know, an authentication protocol is needed to perform the authentication process, right? Even though these three cover the framework, but we still need an authentication protocol called the EAP protocol to fulfill the authentication process for the authentication process. That's why EAP comes in the picture. Okay, that's where EAP comes in the picture. So extensible authentication protocol is what it is called. Let me write that down. Extensible auth protocol is what it is called. Is basically is to provide your authentication. EAP is a flexible layer 2 authentication protocol. Okay, and the supplicant and the authentication server, they communicate with each other using EAP protocol. So the supplicant looking to get the access and the AS authentication server, supplicant, they communicate via EAP protocol with each other, right? Anyway, the authenticator in between will allow the traffic to pass through via the uncontrolled ports, whereas they'll block all of the traffic unless the client is authenticated via the controlled ports, right? This was all about what supplicant and authenticator and the authentication server does. Now I'm gonna move to the next video, because in which I'm gonna show you step by step as to how EAP works and how a client gets authenticated. I'm going to draw a diagram for you so it becomes more clear, because understanding EAP becomes very, very important if you want to understand the security, wireless LAN security mechanisms. So I'll go to the next video and then explain you the entire process of EAP and how from step number 1 to step number last what really happens with EAP authentication, right? So see you in the next video.